work the same over and over. Maybe the factor might have threw you off a little bit. Again, when you give your final answer, make sure you rewrite the whole thing. Just rewrite the whole thing. This had fractions in it. Keep change flip so that knocks that denominator right down there. Just the short way through it, just bring your denominator down. Questions? Nope. Okay, stop me if you have any questions, or I'm going to be going through these. Okay, factor, you have two factors. Set them both equal to 0. This is a nice one. And actually, you can check them in your graph nicely too. Just put this part in your y1, put this part in your y2. Just make sure your table is exactly the same, and that your graph was the same. I mean, sometimes you should see your graph, but in case you didn't, just look at your table. It's a quick way to check an algebraic equation. Just a y1, a y2. And you make sure that it works. All right, another one not so bad. If you wanted to switch this one around so that that negative is in the middle, absolutely, that's commutative property. You could switch those around. You have any homework?
Yeah.
Okay, yes?
I think I know the answer to this question. You don't care which one's A, which one's B.
No, but your A and whatever it is, this number should come over this. Well, in this case, it's both ones, so yeah. But in the end, it'll work itself out. The position might be different, but that's commutative property. You could switch them. It's not a bad question because a lot of kids always ask me that. How do I know which one's A, which one's B? Same thing when they set up let statements. How do I know which one's X, which one's Y? If I put an X up and they have a Y, some kids are a little nervous about it. But it is whatever it is, and it comes back to your let statement. I think this one's missing the page up here. We get this one now? Okay, were you guys able to get those factors? 2 is a prime number. 1 can only go 1 and 1.
What?
Did you get those factors?
No.
Good.
Wait. Yeah, I did.
Okay.
Yeah.
Did we get those factors?
Yeah.
Here's the factors.
Yeah. I got 3, -2.
Yeah, I got -3.
Okay, so let's see what happens. So if we,
I'll look at the one.
this is 61. Did I miss one? Did I pass one?
No.
Okay. So see if you can trace your step back. Check each part. Here's where I set my x equal to 0. And the other x equal to 0 is here. Here's the other x equal to 0. Plug it in. Be careful of this guy here when you subtract a negative. Also this one here. -2 minus 3 gives you -3 if you came out with opposite signs.
I thought -2 minus 2 is
-2 minus 2, yeah, but this is -2 minus 1.
Wait, but you said -2 minus
-2 minus 1 is -3. I'm just looking for places maybe you guys made a mistake. Over here, don't forget, this is the opposite and add. This is positive, this is negative. Check your positives and negatives.
Yeah, I plugged in the -1, but for some reason, I put in a 4, and 5 minus 4, I don't know.
It's usually just a computational mistake.
Yeah.
The process is the same. It's usually you did something maybe computational-wise, and I usually notice it's in a fraction or it's in a negative sign. Over the years, those are the ones I look for. And again, easy way to do this, y1, y2. They have to be the same, they're an equal sign. Tony, you good there?
Yeah.
Okay. Everybody good with this one? Alrighty. Alright, next one. Boys in the back, we good? And factor, those factors are not bad. These factors are not so bad because the concentration of it is on the separation. Questions on this one? Am I getting that you all like these fractions? Wow. This is the first in this class. Okay. This one, they had the graph in the book, so I copied it over too, just so that you could see what the graph looked like. And they had y equals. Do you still do it the same way? Yeah. I don't know what that little 2 is there for. I don't know where that came from. Questions?
This might be like related to the A and B thing, but I have negative 2 over x plus 3 over x minus 4 down.
Negative 2 over x?
Yeah, I did the same.
That shouldn't happen, even when you switch them around. Are you here? Okay, yours is. What does yours say? Okay, it shouldn't happen. It shouldn't change the equation though. So then x is equal to 0 and x is equal to 4, right? So let's plug a 0 in here and solve for this. So this is negative 4. So b is going to go over.
Wouldn't it be positive?
Yeah,
And running
it would be. But it still should come back to the same thing. Because you started out with this. Right? So your negative 3 is still going to come over your x. Or your positive 3 is still going to come over your x. Right? It has to come out the same way in the end. Yeah. Probably just put it over the wrong thing. Just be careful of that. Can you switch them around? Absolutely. Do they have to be in that, that order? No, but they do have to fall the same direction. Is that the last one? No. And the last one? There's the last one.
We never had vocab for this thing.
No. No. I gave you a break here. Really, there's not a lot to do. Matrices more so, but not themselves. Okay, again, get rid of that denominator. Just be careful on the left-hand side because you're going to substitute. If you want it distributed first before you do substitution, that's fine. You okay with these? You're given 2 points and you have to find the equation of a line, right? We give you 2 points and we say find the slope, find the intercept, or you can plug it into the point slope formula. You can plug it into your calculator, L1, L2. You can do y equals mx plus b, plug the points in, find the b. You know how you come up with the equation of a line? So this is a parabola. I'm going to give you 3 points and you're going to come up with the equation of the parabola. The nice part about checking this is you put that in your y equal and you look at your table and you see if your points are there. So it's nice to check. Now, all we're going to do is take these 3 points and fit it into that equation. So because we have x, y points, we're going to plug in your x and your y. So your variables are going to be these guys. Your variables are going to be these. And so therefore, 3 points, 3 variables, 3 equations. And we're going to solve them like a systems of equations. Make sense? So the only thing you have to make sure you do is make sure you line these up correctly. I like to put my x and y just because as I'm plugging them in, I go back to this. So we're just going to take this and we're going to fill this in. So where you see an x, you're going to fill in your x. Leave your variable. So we're just going to plug these in, and then we're just going to reduce these down. So this gives me 1a minus b plus c. Great. And we got to be equal to y. I forgot your y equals. And y was 3. I forgot your y. Your y is the 3. Plug in the x, but the only thing you have to be careful about is you get the x in there and you get the y in there. So this is your first equation. We're just going to do these with all the points. We're going to do it again for each point. They're all obviously going to have a, b, and c. So again, the y equals a times the 1 plus b times the 1 plus c. So this is going to give us 1 a plus b plus c. So you can kind of see right away, you can combine it, eventually get rid of the b. This is what we're leading towards. The last one, do the same thing. The part I shouldn't talk while I'm writing, because if I mess up here, we mess up big time. So you guys need to check on me when I talk and write at the same time. Okay, so we have 3 equations, 3 variables. And now all we need to do is work our systems of equation magic. So we can call this equation 1, equation 2, equation 3. What would you like to eliminate? B. B works out kind of nicely here, right? So we're going to take equations 1 and 2, and we're going to eliminate the B. Keep your work as organized as possible, because you're working with a lot of things going on here. So when we eliminate, we get rid of the B. This is equation A. Now we have to take two others and eliminate the B. Which ones would you like to use? 1 and 3. One has a negative, one has a positive. That works out nicely for us. So we'll use 1 and 3. Okay, and we have to multiply the top by what? 2. Just a positive 2. And when we do this, we eliminate the B. You don't want to, remember, you don't want to have two equations at this point and have 2 different variables in them, because you won't be able to work with it. So you got to remember that you have to keep working on your same variables. All right, so now this is our B. So we're going to come over here, A and B. And we're going to see what we can eliminate. What would you like to eliminate? A. So I'm going to multiply this guy by what? Negative 3. I want the 6's to be the same. I want this one to be an opposite sign. So now when I eliminate this, this happens to eliminate 2. I get negative 3c. So what is c equal to? C is equal to 0. Keep an A, B, and C thing going on over here. Okay, now, back up into one of those original 2. The A or the B. So which one would you like to work with, A or B? A works for me. So we're going to plug in a C of 0. And we'll solve for A. So that's wiped out. So A is what? 2. Now go back to one of your original 3 and plug it in. Which one would you like to use? 2? 2 works for me too. It doesn't matter which one you use. When you use one, you can always check it in the other, but this one's even nicer to check because you're going to plug it in your calculator. So we've got 2 plus B plus 0. So B is negative 1. Okay, now all you have left to do, because you need to find the equation, you just have to plug it back into here. A is 2, B is negative 1, C is 0. Don't forget to plug it back in because the question says find the equation. So you can put that in your y equal, in your calc. You can look at your table, and you can see, in fact, if all 3 points are there. Easy way to check. Nice way to check. It is time consuming, and the biggest problem I always find with kids, when you have to go back to check something, they're like, what did I multiply this by? That's why it pays to write out each step. Like some kids will say, can I just write that statement here? But if you make a mistake, you don't find it. So my advice is, even though like this one's easy, there are ones in here, I know it's AB plus A plus B plus C, write it out. Because when you go to check it, if those are the parts you missed, you're never going to find that mistake. Also, I like to label so that I know where I'm going after that. It's very hard, as you know, for your systems of equations to go back and find your mistake. Even ask a friend to look at it. You okay with this, guy? Now we're going to do the same thing with the circle. The circle is usually a little bit easier because if you think about it, the circle can't pass through too many points that are nice points without being radicals or fractions or something else. So, like, think about a circle with the center of 0. When you make a radius of 5, where is it really passing through? 5, 0, the 0, 5. Maybe we get a point on the surface somewhere, but most of them will be like off, not whole numbers. So these are really not that bad to do. Here's your formula of a circle. This is your standard formula. If you had this, you would complete the square to do this to get your actual x minus h squared plus y minus k squared equals r squared. You would have to complete the square to get there. But we're not making you do that. All we're asking you to do is you're going to find D, E, and F, and just plug it back into this guy. Again, these are the 3 points we give you. This one's a little harder to check without completing the square. This is your x, this is your y. So we're just going to plug those in for x and y, and they're all going to be 0 equals. They're all going to say 0 equals. So your x and y are just going to go in as x and y's. Be careful because the variables change. F is your constant. So when you get here, most of these are going to cancel out. So what do you get? 0 is equal to f. We just eliminated 2 variables and solved for one of them. Most of them will work out this nicely. Do this guy. Remember, they're all 0 equals. This is the x. Watch the squaring of a negative. fix this line up. So you get, this is going to be a 4, and 0 plus 4 is 4. The D comes out, you get a negative 2E plus F. Good? Jackson, good with you?
Oh, yeah.
Perfect? Good. Okay. Set the next one up. X and Y. Again, I know sometimes it's easy to get to that equation, but write it out, because if you've made that mistake there, you won't find it. So this gives us, together, this gives us 9. Now we have 3 equations. So make your life easy. The first thing you can substitute in is what? The 0. So if we substitute the f of 0, don't we lose this and lose this? We'll make life easy. So now we have 2 equations. Like I said, the circle takes longer to set up here, but nicer when you work it out, because there's not a lot of points you're going to get. Because the f is 0.
Oh.
So we're just going to substitute in the f of 0 right away. Okay, I just didn't rewrite the step. So we're left with this. Can we solve each one of them for their variable? Yeah. So let's solve this guy first. So again, make a D, an E, and an F. And do the same for this guy. Negative 9, and D is negative 3. Okay, now this one, once we plug it in, is a little harder to check without completing the square, but don't forget you need to find the equation, so all you need to do, now your variable stays x and y, but you just need to substitute your D, your E, and your F. F is just going to disappear on a 0, but your D and your E have to be put in here. And your F is 0. Now, if you wanted to, you could go complete the square, make sure they're there, or just take one of those points and plug it in. Just take the point and plug it in and make sure that it works. So if I pick the 0, 0, 0 would come out here, 0 would come out here, and here, 0 is equal to 0. Check. Okay. Easy? Not bad. So now you can find the equation of a parabola, given 3 points, and the equation of a circle, given 3 points. And you know how to do the equation of a line, given 2 points. Ready?